So this is chapter 24, section D, and it's the last section in the chapter, and actually in the chapter and in the entire book. And it's on quantiles. And we'll start by considering a population of crabs whose length of shell is normally distributed. So we've got a population of crabs. We're talking about the lengths of their shells, which are normal. And we know that the mean is 70 millimeters. And we are also given sigma, the standard deviation, is 10 millimeters. And a biologist wants to allow only the largest 5% to be harvested. So of course right away I want to draw a picture before I even know anything else. I am going to draw a picture. So it's normally distributed, my typical normal curve, and the largest 5% would be up here somewhere, right? So that's the probability is 5%. 0.05 is the probability here. So P is 0.05. So notice in this case I know P, whereas I do believe in 23 or 24B, or previously we were finding the P if I remember right. Yes. So up till now we've been finding the probability. Now we're given the probability and we're going to work backwards, and we want to know the value here called the K value. So quantiles are also called K values. So it's the opposite of what we've been doing. Before we had the X value or the K value and we found the percentage. Okay, so on our calculator, we'll get to do this on our calculator. And the calculator is formatted so that it's going to find X is less than or equal to K. And let me get the notation here. So the probability that X is less than or equal to K, in this case, so the calculator is going to be finding this probability, which obviously would be 95%. So when you use your calculator, you have to think about it that way, 0.95. And in order to do this, because this is the opposite of what we've been doing, it's the inverse normal curve. So we go to inverse norm, which is again under second vars. Same old place we've been going. So second vars, you'll find inverse norm, and then the syntax is, sorry, the probability, the mu, and the standard deviation. So we will be typing in inverse norm. In our case, so it's, like I was saying, it's defaulted for less than or equal to, so we have to do the 0.95. You have to be careful there. That's a common or a potential place for an error. Mean is 70. Standard deviation is, where'd it go? 10. Okay, so we'll go to our calculator and do this. Second vars, like always. Notice inverse norm is the third option right up there. And then we've got 0.95, sorry, 70, and 10. And we get 86.4. That's the X value or the K value. Let's make sure it makes sense. That's why I strongly recommend you draw pictures every time. So we know the mean is 70. We know the standard deviation is 10. So another 90. So here would be... So it is reasonable. 86.4 is reasonable. It makes sense. And then the units would be, oh gosh, what was it? Millimeters. So again, please draw a picture. Please look at your answer and check it and make sure it makes sense. Okay, now we'll go and do example 7. So that wasn't even an example. That was just an interesting problem. I don't want to lose my sound here. Sometimes I step on the cord and it might come out. Example 7 says, if x is normally distributed with a mean of 23.6 and a standard deviation of 3.1, I just ate rice cakes, kind of stuck. Find k for p x is less than k equals 0.95. Oh, so that's just a really straightforward problem. I don't even know that I need to do that. So it's just what we did before. I'll just tell you what you put in your calculator. Inverse norm. And right up it's just 0.95, the way that that's written, because it's written right like so. And the mean, and then the standard deviation. And when you put that in your calculator, you should get 28.7. And you can draw a picture to make sure it makes sense. They're saying they want the probability that x is less than k is 95%. So if the k value is going to be such that 95% is less than it, it's going to have to be up here, isn't it? So that all of this is 95%. And then look at the mean. The mean was 23.6, and the standard deviation was 3.1. So, this is around 27 something or so. And then we got 28.7, so that's reasonable. It's above the mean. It looks about right. So this is a quick little check. Example 8. Oh, this is a good one. If z, if z is the standard normal distribution, so we're on a z distribution this time. So right away, I'm going to draw a picture. On a z distribution, what's the mean? It's always 0. What's the standard deviation? It's always 1. And so on. So I know that's the picture I'm dealing with. And then it says, find k such that my ST is my such that, the probability that z is greater than k, so we have to be a little careful there, is 0.73. So my k is such that the probability greater than it is 0.73. So if I'm right here at 0, that's 50% is over here. K is going to be back in here somewhere. I guess I could think kind of hard about it, but it's somewhere around in here. This area here is 73%. But our calculator only does probabilities that are less than or equal to. So what we have to do is we have to figure out this probability, which would be 100 minus 73. So that's 27%. That's the number we're going to be putting into our inverse norm. So it's going to be because remember we do the probability first. 0.27, and then, the mean, it's 0. And the standard deviation is 1. So I'll go ahead and do that again on my calculator just so you can see again. So we'll bring it over here. These are kind of fun in a way, I guess. Second bars, inverse norm, enter. And then we've got 0.27, 0, 1, enter. Negative 0.613. Oh, that's fantastic. That's about where I had it, isn't it? Right here. So, when you have your picture, you don't even hardly have to check these answers in the back of the book, because I know I had to have done it right, or at least a pretty good chance that I did it correctly. Okay, moving on to example 9. On this one, we have a university professor determines that no more than 80% of the year's history candidates should pass the final. No more than 80% are going to pass. He or she is deciding this. The exam results were approximately normal, so it's a normal curve, with mean 62. Standard deviation 13. Find the lowest score necessary to pass. Okay, I'm going to draw a picture. Can't emphasize that enough. I'm going to sound like a broken record, huh? Okay, I've got a mean at 62. I've got a standard deviation at 13. So let's see, what is that? That's 75. Minus 13. I don't do math fast in my head. So that's 9, 5, 49. And no more than 80% will pass. So I have to think about that for a sec. The top 80% passing, that's all of these guys back, somewhere back in here, right? We'll call that 80%. So for this K value, I'm just kind of roughly estimating, I don't know exactly where it's at in here, but it's somewhere back in here. Here's your K value. So that means we need to find the K, and again our calculator has to do the less than or equal to K, so that means we need to figure out this area, so that's 20%. Be careful on these, don't just, you got to think about it. That's why a picture is so helpful. And then inverse norm, the probability is 0.2, the mean is 62, the standard deviation is 13. And then we'll go ahead and put that into our calculator, and let's see what we get. Oh, okay. Just a sec, I've got a little bit of an interruption. Yes? Mr. Christensen's room. Yeah, I don't know. They're probably locked up right now. Sorry about that. Okay, sorry about that. Inverse norm. Okay, second bars. 0.2, comma, 62, comma, 13. Oops, no plus, no plus. Enter. 51.1. Alrighty, we'll change colors here. So 51.1, that's about here. Oh, talk about annoying. Okay, 51.1. Whoops. So no more than 80% were passed. So if they got a 51 on the test, that would be more than 80% would have passed, because that would be over here, and then your 80% would be larger. So my K is actually over here. So if it has to be no more than 80, it has to be less than 80. So you're going to have to round up to 52 so that this probability underneath is less than 80. So that's why we have to round up. So it's actually 52. Because if we rounded down to 51, there would be a greater than 80% would have passed. Okay, I think there's 2 more examples. So now, oh yeah, converting to z-scores. So if we don't know the mean or the standard deviation, we have to convert to z-scores in order to find the mean or standard deviation. Good old z-scores. They're kind of cool actually because they're really simple. I actually kind of like them. Example 10. We're doing good on time too. An adult scallop population is known to be normally distributed. I always write that down. Normal distribution. We've got a standard deviation of 5.9 grams. 15% weigh less than 58.2 grams. Find the mean weight, so find mu. Okay, I'm going to draw a picture. I always want to draw a picture. We've got a normal curve. We don't know mean, we don't know mu. We do know that sigma is 5.9. So this, anyway, this is mu plus 5.9. We know that. And 15% weigh less than 58.2. So that means that the 58.2 has to be back in here somewhere. So about 15%, it's about here. Oops. This is 15%. Okay, so we have to think for a sec. What we're going to do to find mu is we are going to change this. We're going to find the z-score that corresponds with this x value, and we're going to get that from that little formula. Remember the z, or was it? It was z. Z equals x minus mu over sigma. Let me make sure I got that right. Yeah, that's correct. So you're going to use that little formula, which you don't have to memorize. It's on your formula sheet. And sorry, we're going to find, well, let's just do it. So I know the x is 58.2. I don't know z, so I'm finding z. X is 58.2 minus mu, I don't know, over sigma. I'm thinking for a sec, kind of. Okay, we have two unknowns, so I've got to think about this for a sec. Oh, I know how to do this. This is what we're going to do. We find the z. The way we find the z is we use inverse norm. Because we have all the information we need. We have the percentage, the 0.15. We know the mean for a z-score is 0. And we know the standard deviation for z's is 1. So we can automatically find the z right away by using inverse norm. Negative 1 point, and you know what I recommend doing is going out a few decimals because to reduce rounding error. So negative 1.036. Make sure that makes sense. It does, because this is to the left of the mean. Now that will come over here in our formula for z. Okay, and then of course you can multiply by 5.9 and subtract and add and all, do all that stuff. And I'm going to just give you the answer because I know you all know how to do that. So the mean, or yeah, the mean. I'm just checking my work here. Let's find it. Okay, I gotta find it in my notes. Here it is. 64.3 grams is what I got when I did the mean. I think when I did it though on my notes, I maybe didn't round out this far. I don't know. Anyway, hopefully you got something like that if you tried it. Oh, that's done. We're done. We finished it. We found the mean. Let's make sure it makes sense. 64.3. Yeah, it does, because if you subtract by about 6, you get around 58. Oh, wait a minute. 15%. So let's thinking about it. Well, I'm not going to spend up to, this seems a little odd. 64.3 minus, I'm just going to check some. I just want to make sure it makes sense. 64.3 minus 5.9, 58.4. Huh, one standard deviation. Was that? I'd have to look back. 38, there was like 38%. I guess, because this was 13 plus, yeah, I guess it makes sense. Anyway, I won't waste any more of your time there. The very last example is right now, example 11. Okay, this one says find the mean and the standard deviation if it's normally distributed and P, the probability of that x is less than or equal to 20 is equal to 0.1, and they're giving us two pieces of information. Probability x is greater than or equal to 29 is 0.15. Super important to draw a picture to get this organized. We have a normal distribution. We don't know the mean. We don't know the standard deviation. And we do know that the probability that's less than or equal to 20 is 0.1. So that means 20 must be down here pretty low because 10% is less than 20. So I should probably have these little areas memorized a little better. Anyway, somewhere back in here, 10% is less than 20. And somewhere up in here, because it says the probability that x is greater than or equal to 29 is 0.15. So somewhere up in here, 15% is greater than 29. So that's the information I'm getting from that. Okay, we already know that in order to find the mean and the standard deviation, we need the z-scores. So we can go ahead and find our z-scores first. This one is fairly easy. So we have inverse norm, because it's already set up right to be less than 0.1, and it's going to be a z-score, so 0 and 1. Whoop, too far. 0.1, 0, comma 1. Negative 1. I'm going to go out a few. Negative 1.282. That's my z-score for that one. And then this one I have to subtract from 100. So 100 minus 15 is 85. So 0.85 would be the probability of all this stuff here under the curve. And then it's 0 and 1. I always go too far. 1.036 is this z-score right here. And that makes sense too because it's bigger than 1 standard deviation. Alrighty, now that we have the z-scores and we have the x's too, we can put these two pairs of information into the the z equals x minus mu over sigma formulas. So we'll do that for each set. So the first one, the z is negative 1.282 equals the x, which is 20, minus the mu we don't know, over sigma. And on this side, we're going to have the z-score, 1.036 equals the x-score, 29, minus mu over sigma. And that's just a matter, we've got two equations, two unknowns. It's a matter of solving those. I personally would like to just solve for mu. I mean, you could decide how you want to do it. I'm going to use substitution and solve both sides for mu. So I'm going to multiply by sigma. Those cancel. I'm going to subtract 20. And then I'm going to have to divide by negative 1. So I'm going to have to negate these. And that will be mu for that one. So I'm going to be multiplying both sides by sigma. 1.036 sigma. I'm going to be subtracting 29. Then I'm going to have to divide both sides by negative 1. I'm kind of doing that in my head. You can pause and do it by yourself slower if you want, but you should get these as your results. And now we can set those equal to each other. And if you do the simple algebra, what I got when I did it, I don't know if I went out to this many decimals though. Oh, it looks like I did. Well, maybe not. I got 3.89, but I didn't go out to 2.82. So if you got to 2.82, you might get something different. Maybe I will redo it just to see. So add that. See, I had a calculator when I did this. 8, 11, 1, 3, 2, sigma. I added that. Subtract 20, you get 9. Divide. 9 divided by 2.318. 3.88. Yeah, because I had 3.89. So this is more accurate. Make a note here. And then, so that answers one of our things. And then, we probably should put units on there. Anyway, I don't know what they are. then you could just simply plug that back into either one, probably into this formula right here. Let's just do that and see what we get for mu. 1.036 equals 29 minus mu over sigma. So on to the calculator. 1.036 times 3.88. So multiply, then subtract 29, and then negate it. So it's going to be 24.98, which rounds up to 25.0. And there's the mean. So there you have it. That's the last example. We'll see you in class.